với các bộ phận bị tổn thương của con người bằng công nghệ này.
Ghi nhận từ hội thảo công nghệ in 3D kim loại những đột phá trong phát triển sản phẩm và sản xuất một số ngành công nghiệp vừa diễn ra tại thành phố Hồ Chí Minh. Tại hội thảo, các chuyên gia đã chia sẻ giải pháp ứng dụng in 3D kim loại vào lĩnh vực y học khi chế tạo được những phần xương nhân tạo từ vật liệu titan. Những phần xương này có tạo hình hoàn toàn khớp với cấu trúc của đoạn xương bị thiếu, được cấy ghép vô cùng chặt chẽ vào cơ thể người. Sản phẩm này được tạo ra qua quá trình bồi đắp vật liệu theo từng lớp chồng lên nhau, một xu hướng mới trong ngành in 3D hiện nay. Công nghệ này đã được chứng minh độ an toàn trong lâm sàng và đã được áp dụng tại các nước như Mỹ, Trung Quốc.
Cái công nghệ bồi đắp này đó là nó sẽ đắp dần từng điểm vật liệu, nhựa hay là kim loại, sẽ thiêu kết từng cái phần tử vật liệu ở dạng bột kết nối với nhau để tạo thành cái sản phẩm. Và hiện nay nó có những cái ứng dụng đặc biệt liên quan đến y học tái tạo. Có thể nói là đây là một cái triển vọng cho cái lĩnh vực y học tái tạo ở trong nước.
Lĩnh vực mà in 3D áp dụng vào ngành y tế là một trong những cái mảng mà được ứng dụng nhiều nhất ở trên thế giới. Và cái in 3D cho cái ghép y tế là nó rất là tối ưu, không chỉ là về mặt độ chính xác, kích thước cho từng người, cá nhân hóa cho từng người, nhưng mà nó còn giúp là kết nối với xương tốt hơn và nó tạo ra cái hiệu quả tốt hơn nhiều trong cái việc mà cấy ghép trong y tế.
Vinotech hiện là một trong những doanh nghiệp đầu tiên đầu tư công nghệ in 3D kim loại vào lĩnh vực y tế tại Việt Nam. Công nghệ này sẽ giúp chế tạo các thiết bị hỗ trợ quá trình phẫu thuật nhanh và chính xác, chế tạo các bộ phận cấy ghép trong cơ thể người.
Gần đây chúng tôi đã lắp đặt một cái hệ thống máy của hãng SM Solution cho một cái khách hàng rất là lớn ở Việt Nam, chuyên làm trong cái mảng cấy ghép y tế. Và trong vòng 1-2 năm tới đây thì chúng ta sẽ thấy là những cái sản phẩm sẽ được làm ra tại Việt Nam, và tôi tin rằng đây là cái lĩnh vực mà Việt Nam sẽ phát triển rất là mạnh trong thời gian tới.
Để mà có thể áp dụng các cái sản phẩm này cho bệnh nhân thì phải trải qua một cái quá trình thử nghiệm lâm sàng và qua cái sự chứng thực của cái hội đồng y Đức để người ta khẳng định rằng cái việc thay thế này là an toàn cho bệnh nhân. Và trên thế giới đó, nhiều nhất ở Mỹ hiện nay người ta sử dụng trong cái thay thế khớp gối.
Những năm qua, ứng dụng in 3D đã tạo nên nhiều phép màu khó tin cho lĩnh vực y khoa, chăm sóc sức khỏe con người. Không bao lâu nữa, các bác sĩ tại Việt Nam đã có thể tự tin sử dụng công nghệ này để tái tạo một số bộ phận cơ thể người, mang đến cuộc sống chất lượng hơn cho người dân.
Vừa qua, chương trình Cà phê Tech kỳ 6 với chủ đề ứng dụng in 3D kim loại trong ngành y tế và một số ngành công nghiệp do Hội Tự động hóa Thành phố Hồ Chí Minh tổ chức tại Trung tâm Hỗ trợ và Phát triển Doanh nghiệp Thành phố Hồ Chí Minh. Chương trình với sự tham dự của tiến sĩ Đậu Văn Hậu, giám đốc Vinotech, báo cáo về các nội dung ứng dụng in 3D kim loại trong ngành y tế.
Dần theo thời gian, các cái giải pháp in 3D kim loại bắt đầu xuất hiện và ngày càng được giải quyết những vấn đề.
Trong y học là một xu hướng mới để ứng dụng trong công tác giảng dạy, học tập, nghiên cứu. Công nghệ này không chỉ mang đến những hiệu quả tích cực cho công tác quản lý, khám chữa bệnh, chăm sóc sức khỏe, mà còn có vai trò đắc lực trong việc hỗ trợ đào tạo nguồn nhân lực y tế có chất lượng. Đây còn là cơ hội để các bác sĩ, chuyên gia muốn tìm hiểu thêm về công nghệ in 3D có thể cập nhật những kiến thức và ứng dụng của in 3D trong y tế.
Xin thay mặt ban tổ chức thì xin chân thành cảm ơn toàn thể các quý vị khách quý cũng như là các bạn hữu đồng nghiệp cũng hôm nay đã đến đây để tham dự chương trình này. Xin cảm ơn.
Chú chọn 𝐬𝐳 thì sẽ mang lại lợi nhuận.
Hôm nay lần thứ 2 mình tham dự cái sự kiện Tech Series của MedLab tổ chức. Lần này tổ chức với một cái không gian rộng hơn, chuyên nghiệp hơn và có số lượng các cái gian hàng và các diễn giả nhiều hơn. Lần trước là 5 thì lần này là 8. Và ấn tượng chung vẫn thấy với cái nội dung của ngày trình bày là rất là đi vào có chiều sâu và phù hợp với các cái khách hàng thuộc ngành điện tử là đối tượng khách hàng mục tiêu của ngày hôm nay. Và tôi cũng sẽ rất kỳ vọng các cái phần trình bày, chia sẻ cũng như các cái gian hàng là tạo ra được sự thu hút đối với những người nghe.
Sự kiện ngày hôm nay thì mình thấy là mang lại rất là nhiều thông tin hữu ích, đặc biệt là về các cái ngành nghề mà mình quan tâm, và đồng thời bên mình khi mà làm giải pháp tự động hóa thì cũng cố gắng đem lại những thông tin tốt, thông tin hữu ích với chương trình. Đối với bên mình thì một cái định hướng về tự động hóa nhà máy, rồi là các cái giải pháp, các cái công nghệ mà bên mình có thể cung cấp. Thì hiện tại một cái hiện trạng đó là sử dụng nhân công rất là nhiều trong cái hoạt động sản xuất, và sắp tới thì cũng có cái sự thiếu hụt nhân công nếu như mà cái làn sóng di chuyển sản xuất từ Trung Quốc sang. Từ đó thì bên mình cũng định hình được cái vai trò của tự động hóa trong nền sản xuất.
Good afternoon. Our webinar on the application of 3D printing in the footwear industry is about to start. Please take a moment to find a comfortable seats. Ensure your network connection and sound system so you can fully engage and participate in today's webinar. Thank you. Once again, webinar 𝐜𝐚𝐥 will officially begin in a few minutes. Please quickly find the most comfortable seats for yourself, ensuring network connection and sound system to have the best experience. Thank you very much. This webinar will be in English, so you can turn on the live caption by following the instruction given on the screen. Ladies and gentlemen, no more waiting. Welcome to 𝐜𝐴. My name is Ivy and it's my honor to be your host today. First of all, allow me to send the warmest greeting as well as the best wishes to the speakers and the audience attending today's event. Today's event is an online seminar, Go No Chemical, 3D printing in the footwear industry, co-organized by 𝐕𝐢𝐧𝐃, a pioneering in metal 3D printing, and Materialise, a leading company in the realm of 3D printing software and services. This webinar will show you the impact of 3D printing in the designing shoe sole and how it can eliminate the presence of chemicals in the mold making process. Share with us today, we would like to introduce from 𝐕𝐢𝐧𝐃, Mr. Huân Đậu, CEO of 𝐕𝐢𝐧𝐃. From Materialise, Mr. Moon Chun Lim, General Manager, Southeast Asia, Australia and New Zealand, India. From Materialise, Mr. 𝐜𝐴𝐴 Law, Sales Engineer Team Leader in Materialise, Malaysia. Ladies and gentlemen, and it's now my pleasure to introduce Mr. Huân Đậu, CEO of 𝐕𝐢𝐧𝐃. He will have a small speech before we start the event. Let's welcome him.
Thank you, Ivy. A very good afternoon to distinguished guests, ladies and gentlemen. First of all, thank you, the speaker from Materialise, Mr. Moon Chun Lim and Mr. 𝐜𝐴𝐴 Law, for presenting a very interesting topic today. Before moving on to the presentation, I would like to quickly introduce 𝐕𝐢𝐧𝐃. Let me share the screen. Okay, do you see my screen?
Yeah, we can also see your screen.
For today's event, we are speaking in English, but for those of you who are interested, please also turn on the automatic caption, which was shown before. So now I would like to quickly introduce 𝐕𝐢𝐧𝐃. So 𝐕𝐢𝐧𝐃 is a company focused on the 3D printing technology, especially in metal 3D printing. We are providing the 3D printer, metal 3D printer from the leading brands such as Nikon SM Solution or from 𝐜𝐡𝐼𝐼. We are also providing the post-processing equipment for the customer. Beside the hardware, we are also providing a software solution. We have software from Materialise and Hexagon, and we are also providing the engineering service like design and simulation service for different industry. We are also provide 3D metal printing services. So 𝐕𝐢𝐧𝐃, we are focusing on providing end-to-end solution for customers. So not only the 3D printer, but also the complete workflow of AM that start with the part design to simulation, modeling, process planning, 3D printing, and post-processing steps such as depowdering, heat treatment, and surface treatment. In terms of hardware, we are the distributor of Nikon SM Solution. It used to be SM Solution, a company based in Lübeck, Germany. This is a leading company in metal 3D printing. So they are the one who invented the SM technology, and this is the range of product from SM Solution. It starts with a small system like SM125 to the largest one is the NXG12 600 with a very big view volume, 600 by 600 by 600, and with 12 lasers, so the printing speed is very fast. Besides SM Solution, we also distributing 𝐜𝐴𝐼𝐼 system. This is the technology called cold spray. It's very applicable for repairing those engineering parts, or it can also be used to build up new parts with very high speed. So 𝐕𝐢𝐧𝐃 is proud to be the distributor for Materialise in Vietnam as well. So as we know, Materialize is one of the leading company in the world for 3D printing solution, especially in software. We are providing three types of software products here. Include Magic is a slicing software, and 3Matic is a very powerful design software that can be applied to various industry. For today, we focus on the shoe industry, but it can also be used in other industries such as medical, aerospace, etc. And Materialize also have a very powerful product called Mimic, is being applied to medical application. So 𝐜𝐴𝐻𝐿𝐴𝐻 is also authorized distributor of Hexagon. So one of the product is Apex Generative Design. It's also a design software that very suitable for 3D printing that could have create very complex part and save material, save time for designer. So the second product from Hexagon is the Simulfact. So for Simulfact, it includes Simulfact AM for 3D printing, and Simulfact welding, Simulfact forming, etc. For Simulfact AM, it can be used to simulate the whole 3D printing process and can predict or identify the potential risks of the printing before actually starting the printing. It can also have to optimize the design and post-build operation as well. So that is a very quick introduction of 𝐜𝐴𝐻. So if you have any more questions, please don't hesitate to contact us. Thank you so much, and back to you, Ivy.
Thank you, Mr. Huan, for your sharing and for introducing 𝐜𝐴𝐻. And now we'll move into the presentation of today. Let's welcome Mr. Moon Chun Lim with the presentation about efficiency, innovation, and sustainability, harnessing digital texturing and additive manufacturing in footwear creation. Let's welcome him.
All right. Hello, everyone. Thanks, Ivy, for the introductions. And also, I would like to thank 𝐜𝐴𝐻 for inviting us to be part of the speaker for this webinar itself, as to share information about how 3D printing is being used in the footwear industry. So my name is Mun Chun. So I'm the channel manager who look after the Southeast Asia, Australia, and also New Zealand region itself. Today, I'll be presenting on the topic of the harnessing digital texturing and the role of additive manufacturing in footwear creation. I'm pretty sure everyone in the webinar itself is that know what 3D printing is or what additive manufacturing is. In fact, the technology is a growing technologies based on the various different market research report that you have seen over here. Is that it is actually a growing technologies over the year in the future, and it's on an average of 24% market growth is expected until 2023. And in fact, throughout the last few years itself, we do see there's a tremendous growth of adopting 3D printing in the industry itself. It is actually driven by a digital transformations agenda, and is currently at a technological and economical inflection point with potential to reinvent and disrupt the global manufacturing sector. So despite we have actually seen a rapid growth of adoptions in 3D printing or additive manufacturing itself, but if you look at the overall manufacturing industry itself globally, it's only represent around 0.1% of the global manufacturing output, estimated at about 12.7 trillion itself. So you can see that 3D printing has a lot of potentials in the manufacturing industry. Today itself, we'll be focusing more on the footwear industry and to see how 3D printing is bringing values to the industry. Traditionally, 3D printing has been known its value in footwear prototype creation. So 3D printing has been used to actually print out the design for evaluation and also for concept modeling and rapid changes on the design itself before proceeding into production. And the technology has been evolving since is that it has moved beyond prototyping itself, and now it's actually gone towards using it as a manufacturing aid for metal mold creation, which I'll be explaining a little bit later on as well. And there's even some companies in the globe itself is already started to use 3D printing itself in direct footwear manufacturing. So if you are aware of like Adidas, there's a product that's actually launched in the market, and you go to the shopping malls, you can see that the Future Craft 40 is actually a direct printed product from a 3D printer itself. So that's the benefits the 3D printing can be shown in the footwear industry. Now, the added value with AM is that there are three different added value. The first will be on sustainability. So sustainability has been a major driver in footwear and also in the apparel industry since the pre-COVID time. And with about 25 billion pairs of shoe producers globally each year, there's a huge opportunity to impact on the CO2 emissions during the production and recyclability at the end of life. So at a 2012 MIT study of greenhouse gases in footwear productions itself, it is found that the manufacturing processes has actually accounted 68% of the CO2 emissions, and the material is accounted for about 29% for a combine of a 97% impact on the CO2 emissions. So this includes about 10% contributions from the scrap generated during manufacturing. So despite, there's a lot of shoes as footwear is being created, apparently there's also a lot of CO2 that's being generated throughout the entire process itself. So what will be the ways that to move forward into reducing that and to protect our environment? The second added value that AM brings itself is about innovation. So with 3D printing itself is that you can create high complexities of textures where the traditional manufacturing sometimes not able to do so. And of course, with 3D printing itself, you can also increase your efficiency. So the mass applications that simplifies the entire production process itself. So we're talking about digital manufacturing directly from CAD files into end product. Now, what I mentioned just now about the CO2 emission, and now we'll be looking into what will be the environmental challenges and the role of manufacturing in sustainable footwear production. Well, the problem is that a typical pair of shoes, it contains about 100 plus parts and involve about 200 plus manufacturing steps with multiple operations such as like injection molding and etc. And throughout the entire process itself, there are a lot of waste and toxic chemical that's being used, especially on applying on the texture itself. And once those acids has been used, is often it is not properly treated, or some of it is actually dumped in rivers and waterways that polluted our environment. And of course, during this process itself, the manual processes of these chemical etchings and use of chemical itself is actually having a poor labor condition that will also affect us on the operator's health. And there's also risk of IP violation. Now, if we drill down into the traditional way of texturing itself, that of the diagram, this illustrates the traditional way of texturing, where you have a 3D model, and then you'll need to go on to a CNC to create a wooden master. And the wooden master itself will needs to go on to create the silicone mold. And the plaster molds will then of the shoe itself will then create from the silicone mold, and from there then you cast the metal mold onwards. And once you already get the metal mold, and then you will need to do some chemical corrosion, or what we call chemical etching, in terms of getting the final textures to be placed on the metal mold itself before moving forward towards the productions of the shoe itself. Now, with the presence of additive manufacturing, this has actually helps to simplify the process, and also the process will be way more environmental friendly compared to the traditional manufacturing. So the process has now changed to simplified in a front end where you have a 3D model, of course, with the mass texturing that is actually applied in the 3D model itself. And along with the 3D model with texture, it is then printed out by using 3D printers, typically in SLA processes. Once you actually get the so-called master pattern that is actually printed out from the printer itself, and you will then move on to do the silicone mold and then plaster mold, and eventually using metal to cast, and at the end of the day, then you will get the textures and metal mold. So this has actually eliminated the chemical corrosion, or what we call the chemical etching, alongside the process that makes it more environmental friendly. Now you may be wondering what I mentioned just now about digital texturing, and what is it about digital texturing? So digital texturing is about using a bitmap with a 2D textures, and with the help of our 3Matic software itself, it will then automatically convert the images into a 3D textures in a 3D model. I'll go into details about it later on, but first let's look at the benefits of digital texturing in footwear industry. Is that textures can be actually applied on multiple different applications, such as like during prototype, you can do the mass stitch texturings in the 3D models and then print it out to do some design review and also concept modeling. And of course, it can be used as a way to do manufacturing and also master vacuum casting parts itself. It has the advantages of ability to use unique and custom textures. You can create your own textures out of it and then apply it on a 3D model. It's a simplified process and faster design iteration. So everything is done in a CAD models, and then you can actually simplify the entire process, and then also reduces the lead time out of it, and of course an IP protection as well. So you need not to actually outsource it to a different third party to do on the printing or to do on the prototype, and also footwear. So that will help you to preserve on the IP protection. And the last we were talking about sustainability, which is one of the key important things that 3D printing can address in footwear industry. So how digital texturing is actually working? So it's a texture shape that is defined by grayscale images. So in the library itself, in the software, you have a different set of grayscale images that you can choose with. But of course, you can also design your grayscale images and use that as part of the texturing process. And then when you move on into 3D surfaces, the software will then unfold it into 2D, and this is what we call a UV mapping. And once you have actually applied the 2D images onto the UV map itself with a set offset value that you have actually set, then it will actually helps to create the textures onto the part itself. So once you have actually applied the 2D textures, you can then convert that into 3D textures in 3Matic software, or you can actually save that as a slice-based texturing and send it to our build processor to process on for printing. So I'll be further explaining on what is slice-based texturing and also its benefits out of it. Now I'll go into the basics of texturing process. So like what I mentioned just now, when you have a 2D textures of a bitmap, which is a black and white gray colored bitmap itself. And then when you have a 3D model, then you actually unfold that into a UV map, a 2D UV map, and then indicate the surface that you wanted to be textures. Place the grayscale images on top of the model itself, and then you can get the texturings out of that with your 3D models. So as simple as that. And of course, during the texturing itself, the texture placement is actually quite important. So textures mapping will determine on the texture placement on the indicator surface. So you can actually move, rotate, or scale the textures mapping itself as to get the desired textures out of it that you wanted in the end. So what will be the bitmap requirements itself is that it must be an image with only a grayscale value. There's no transparencies or colors, and it must be in JPEG, BMP, PNG, and TIF. And of course, the bitmap images must be seamless so that the image can be actually repeated without any visible seams at the edge of the parts itself. So the size and the resolution of the bitmap should also correspond to the expected details out of it. And you can see that from here itself, if you have the seamless bitmap images, then you can actually create a textures that is seamless across on your 3D model. But if it is not seamless and has a visible seams on top of it, then this will be the effect that will be observing at the end of the texturing. So the bitmap requirement is actually quite important that you guys will need to take note on it. Now, move on into mass texturing in 𝐜𝐴 itself. I'll just share how this is applied in the 𝐜𝐴 in terms of mass texturing. So first, you will have the 3D models of the shoe sole, for example, and then you can actually import the files into 𝐜𝐴TIC, and then to do the initial checking of the file to see if there's any errors or any things that is present in the CAD model or STL models. If yes, then we can actually fix the files by using 𝐜𝐴TIC to ensure that there's no errors in the 3D files. Once that is done, you can actually then segment that into 3 different segments by using color-coded. And then after that onwards, based on the different regions that you have actually set, you can then easily add different textures by using 𝐜𝐴TIC into those regions that you have pre-selected out of it to create the textures that you desired. And once that is done, and then you will then be placed the 3D models into another software, Materialize, which is what we call the Materialize Magics, that is dedicated or meant to for data preparation and build preparation, so that you can actually arrange on your orientations and also printing strategies inside. And when that is done, and then you can actually set up on the support that is needed to print out this part. And of course, if you have the build processor that's connected to the printer, and you can actually slice the textures part in our build processor, and that will be ready out for printing. So we can expect that the full workflow itself can be finished in a matters of hours, depending on the complexity of the parts, of course. But with the presence of the software and the availability of the softwares in the market itself, this can actually helps to streamline and also increase your efficiencies in terms of creating this 𝐜𝐴 itself. To put it on a more illustrations on a mass texturing workflow in 𝐜𝐴TIC itself is that, of course, the first will be importing on a CAD file, and then you do some fixings, and then you can actually group those surfaces by different color. So as you can see from the slides at the previous, so there's different colors that I'm actually setting on it. And then, of course, depending on the areas of part, you can then merge and split the surfaces in the best suited way for the texturings to be happen. And moving forward, then you can start to select the different textures in your library to apply on the textures on the surface that's being set. And of course, you can add a split curve in the UVim pages itself, and also maybe scale and assign 3D parameters per group, and of course align the textures consecutively. I've prepared a video to give an illustrations of how this entire process is work. Now I'll play the video.
Sorry to interrupt, but does this video has the sound?
It has a sound, but it's just a very relaxed sound, so it's fine.
Yeah, okay.
Right, so this is just a very quick video to show you guys on how the entire process work and how does it, operates in the software itself. But nonetheless, in the later on sessions, my colleague Casey will be showing you guys on how the software is actually working and how you can actually apply those textures in the 3D model. I'll move on to my presentations. So I've actually talked about the slice-based 3D textures earlier on. So in here, I'll be explaining what a slice-based 3D textures is about. So imagine if you have a footwear that's being textures, very complex. There's a lot of different textures out of it, but in order to print it out by using 3D printers, so often you need to convert those files into STL. So imagine if you have a lot of textures, and then when you convert it into triangles, that will take up a lot of millions of triangles, and that will make the entire files to be very heavy. So what will be happening when the file is actually huge and heavy itself is that during slicing, it will take more time for it to slice. And eventually, if let's say there's any error along the way, then it might have actually a slicing error, then maybe you will need to restart on the process again. So the benefits of 3Matic itself is that we can actually design those textures in slice-based. So what do I mean by slice-based itself is that once you have a large surfaces or detailed textures itself, when you apply the textures on top of it, it won't be actually converting into triangles or what we call the STL, where it will be actually designing it on a slice level. So the advantages of doing it in a slice level is that the file size can be reduced. And then when you send it to the printer that has our build processors connected with it, you can then actually reduces the time that is required to slice the models out of it. So that will actually simplify the process and also reduces the entire file sizes itself. Now I'm giving you an examples over here about the benefits of slice-based 3D textures. So imagine itself is that this is the STL file size before texturing. It has probably about 5.8 megabytes. And then the triangles before texturing itself is about 120,000. Now, after the texturing has been done, so if you are converting it into STL or triangles, the estimated file size will take up about 1.8 gigabyte, or equivalent to about 37 millions of triangles. That is a lot of increase compared to the triangles before texturing. So the triangle count and STL file sizes actually increases about 300 times if we actually applying an STL-based textures out of it. So imagine if you were to send this for printing, then it will take a lot of time to actually slice it, and that may be prone to some errors if let's say there's something that's happening along the way. Now, if you design that in a slice base, the number of textures on the entire show itself is about 453. And then the file size, when you compare it with the STL-based texture, is that it is only reduces to 177 MB. And then the slicing time, the RAM, and then the file sizes tag is also greatly reduces itself. And the results will be depending on of course, the number of textures, the image sizes, the build orientation, define the detail sizes, and etc. But definitely, if you are designing it in slice-based basis, that will help you to, reducing the slice time itself and reduces the file sizes. Now, as technology has advanced, of course, there's availability of metal 3D printing that's available in the market, like what Vinotech has shared earlier on, that they're also providing solutions for metal 3D printing. What does the impact that it will bring to the footwear industry is that with metal 3D printing itself is that it can actually further simplify the entire process. So previously when you have a 3D model and then you print out the master pattern, and then you do the silicon or plaster mold and eventually metal mold out of it. But with metal 3D printing itself is that you can then have 3D model with 3D mass texturing using metal 3D printing to print out the metal mold directly, and then you can use the metal mold directly for mass production purposes, for example. All right, you may be wondering, what Materialize is actually all about and what we are doing in the 3D printing industry. So we are a company that started off since 1990, and we have about 35 years of experience in additive manufacturing solutions. And at the start of the day itself is that we have actually really just focused on additive manufacturing and develop and provide end-to-end solution with a fully digital fabrication method to create products that is unique from scan to design and to 3D printed devices. We also constantly innovate and bring value by increasing efficiencies and creating the otherwise impossible and making more sustainable products itself. And in our Belgium headquarters, we are a Belgian company. Throughout in Europe itself, we do have certified manufacturing as well in creating processes and products for highly regulated industry, for example, like healthcare, aerospace, automotive, and more. And of course, we are also specialists in making products that's unique to the users, for example, like hearing aids, eyewear, and medical implants. And all of this experience is actually gained from the 4 different business units that we have. So the first one will be on Materialize, a software division, which we provide the leading software to manage and control the entire AM processes. There are 92% of the largest metal AM system manufacturers as using our solution globally, and we have actually powered on 85% of the automotive companies of the Fortune Global 500, and also 40% of the top 20 companies of the Fortune Global 500 as well. And in Europe itself, we have another division is Materialize Manufacturing, and we are one of the largest and most complete factory for 3D printing, where we houses about 175 industrial 3D printers with about 25 machines that is on metal 3D printers, and we provide about more than 30 plus materials and also 90 plus finishes as well. Last but not least, we have a medical division, which will be focusing more on the medical side of business that serve the patient-specific treatment. Things like converting DICOM data into 3D printable models, implant design, surgical guide, and etc. And then, of course, the 4th business unit that we have will be on the consultancy services. That's what we call Materialize Mindware, where we have advisory services for business success with additive manufacturing, with the expertise that we have actually gained for the past 30 years itself. All right, we strive to make a difference through a difference in the making. So we are specialists in the end-to-end digital fabrication techniques. And we often, look into customers to see what are the way things are done now, and ask the big questions like how can we actually make a process that's more efficient? How can we actually use additive manufacturing to get a better results and also create the impossible? So that's the value that we are actually bringing in with the use of our software solutions and also experience in additive manufacturing to the industry that would like to adopt on these technologies itself. Yep, with that, this concludes my short presentations and sharing about how additive manufacturing is making its impact in the footwear industry, and how Materialize a solution can be used and to streamline the entire process in footwear industry, and also enables sustainability and eliminate the use of chemical alongside with the process. And feel free to put it in the chat if you have any questions, and also feel free to reach out to me and also to 𝐕𝐢𝐧𝐧 if, let's say, you have any further questions after the webinar itself. And so with that, I'll pass back the sessions to Ivy.
Thank you, Mr. Lim, for your sharing. We all now can see how Materialize 3D can significantly change the process of making the 𝐶𝐶 mold. And now, follow this presentation. I guess probably the part that we've been waiting for is in the very first part of this webinar. We will have a special demonstration of Materialize 3D-matic in action. Casey Law, sales engineer team leader in Materialize, will showcase how this powerful software can be used to design incredibly amazing and distinctive shoe soles. Please welcome Casey Law. And during the demo section, if you have any question or want Mr. Law to show you how to make a specific pattern, please feel free to type down your question in the Q&A section. You can write it down in either English or Vietnamese. We will help translating it. Okay.
Hello, good afternoon, everyone. Thank you, Ivy, for your introduction, and thank you, 𝐕𝐢𝐧𝐧, for again inviting us. My name is Casey, and just now I believe my colleague Manchun have given you a very good overview on how the mass texturing or digital texturing in the shoe shore or shoe mold industry. All right, so with my section now, I'm going to demonstrate using the hands-on the software, and then to show you step by step as a user how you can really create the digital texture on your shoe shore. All right, so feel free to send in your questions in the chat box if you have any. Can you all see my screen?
Yeah, we can all see your screen.
All right, cool. So for this demonstration, I will start with importing a 3D model. After that, I will use 𝐜𝐴TIC, okay, our very powerful design software for file fixing. And after that, to create the digital texture. And this is a very big knowledge inside it, because there are a lot of techniques involved, and our software has been designed that give you a lot of convenience in creating the texture. After that, we'll send the shoe shore with the texture into Magics for build preparation. And here we can generate support. Okay, for example, if you are using a SLA printing or even a metal printing, most probably you will need support on your part. So here we can help you to orientate the part, and after that generate the support. And lastly, Materialize build processor plays a very important role, because as what my colleague mentioned just now, slice-based technology. All right, so this build processor will allow you to slice this part without converting those texture into STL first. Okay, so this will definitely speed up your workflow and decrease the file size. And after that, lastly, we'll go for the printing. So this is an overview of what I'm going to show you in 𝐜𝐴TIC. So I will go with 𝐜𝐴TIC first, and after that to Magics. Don't worry about this, so I will really go through one by one. But what I would like to share to you, let you see is this. So typically, this is the design of a shoe and the component on it. So yep, there are different kind of component, but what we'll be focusing today would be on the outsole. Okay, so the outer layer of this shoe, where most probably it will contact with the floor, and midsole, and also inside there is an insole. All right, so I will be using 𝐜𝐴TIC to create the digital texture on the outsole, midsole, and also some lattice structure in the insole. All right, so let me just open up 𝐜𝐴TIC. All right, so this is how 𝐜𝐴TIC looks like. All right, so it is quite similar to any of the design software in the market, but the most advantage of using 𝐜𝐴TIC in your design is that it is really for 3D printing, because everything that you design will be in the STL file format. Okay, so it is a very good tool for you to use a design for additive manufacturing function that is available here. All right, first of all, let me just import a shoe design. So typically, what kind of file that you can import, right? So can be varies. So let's say if you are using Rhino, which is a very quite a popular tool in the shoe industry that they create the 3D design, or even you are doing other software like maybe SolidWorks, CATIA, or maybe other software. You can also export it as the dedicated file format. Like for example, if Rhino will be in .3dm, or you can export it as like a general file format, like a stat file. Okay, it can be done also. And last but not least, yeah, it can definitely import STL file as well. So let me just import a shoe model that has been designed. All right, first of all, this is, if you look at it, all right, I will go with a simple shoe sole design and slowly move to a more complicated one, okay, so that you can get along on what I'm trying to convey here. So the first step would be, before you can apply any digital texture, let's look at this shoe design first. All right, so inside Trimatics, okay, you have the part list, and inside the part list, you can see basically different kind of surface that has been generated, or the whole surface here, and also the curve list, like for example, this curve, okay, that can be grouped. So this is like all the details of this shoe mole or shoe sole will be here. All right. So if we zoom down into this model, we can see there are some color here and there. Okay. So let's look at the color here. Okay, the red color at the middle. Right. So you can see that actually there are some errors in this shoe model. Okay, red color means the normal of the triangle is inverted. Okay, supposingly the normal of the triangle will indicate where the materials of the 3D printed part lies. So in this case, the material is facing outwards, which is not correct. So our objective here is to make sure that the normal of the triangle is facing inside of the part. Okay, where the materials of the 3D printing lies. And secondly, if we zoom down this area, we can see that there's a hole, okay, inside where you can actually see what is inside, okay, the curvature inside, things like that. All right, so this is some of the typical errors that might be happen, not necessarily 100% will happen, but let's say if you import from your CAD design software, most likely some of the error might be there. If something like this also, okay, like a noise shell, okay, where during the conversion to STL or to dedicated file format, it might happen. And lastly, if you look at the outsole design here, there are two big holes here where you can see inside. All right. So not only you can visualize the errors through your eyes, you can also use the fix button here or fix ribbon here, and clicking the fix wizard. Okay, selecting this part. Okay, so these are the errors that can be seen. I mean, that is categorized. And once you click the button up there, right? So these are the errors that has been summarized. There are around 341 inverted normals. Okay, so why there are 241? So inverted normals are all these red color area. So why there are 241? Because if you look at the triangle view, all right, this shoe mole or shoe model is actually in STL file format. All right, so if you import your part from 3DM as a 3DM like a file source or stat file format, then once you import in Trimatics, it will directly help you to convert into STL file format. Okay, so there are around 241 all these small triangles. That is with the inverted normals. Bare edges, okay, bare edges is something that hard to be detected by eyes, like for example this one. Okay, if you look for the a view far away from this shoe, you can't really see where are the bare edges. Okay, just a small line there. But if you zoom inside, it's actually some disconnected surface. Okay, and there are also some like potential noise shells. As well, this is noise shells. Planar holes. Okay, there are a lot of holes here and there. All right, so how to fix this part? Actually, it depends on how difficult your errors, but you can always try with the auto fix. Okay, by using auto fix, most of the errors has been fixed. Okay, you can see that the red color areas and also the bare edges, the noise shells have been fixed, but there are some here, one here, that is not being fixed yet. But if you look at the back, this hole has been fixed, but this hole has been fixed as well, but you see the surface is distorted. All right. So auto fix can help you to fix most of the problem, but let's say if let's say your just in case like your errors is like quite complicated like this, then you might need some manual fixing tool. Okay. So let me just undo to the original error step, and I will fix this hole first because this hole cannot be fixed automatically. So this hole, it seems like an organic shape hole that I can actually fill with. Okay, there are a bunch of manual fixing tool here that you can use if automatic fix cannot fulfill your requirement. So let me now use a fill hole freeform. Okay, this fill hole freeform is very good for me to patch out a hole with the irregular shape like this. After that, I can go to the fix wizard again, select this part, update the errors. Okay, so there are still many errors because I only fix one hole, and I can use the follow advice. Okay, so these are the advice that 𝐜𝐴𝐷 asked me to perform. I can either go to those functions and click that button, or another method is this software is smart enough to just follow the advice. Okay, and it will help you to fix automatically. So follow the advice. Now I follow the advice again to see, okay, now the error has been reduced. Okay, so the bare edges and the inverted normal has been reduced, and the noise shells have been reduced by some also, but there are still some errors here. Okay, let me just follow the advice again. Follow advice. Follow advice. Follow again. All right, click until, okay, the error has been fixed. Okay, there are still 2 overlapping triangles. Follow advice. But these 2 overlapping triangles cannot be fixed by this follow advice. So what I can do now is mark the overlapping. Okay, so this is the overlapping triangle. And I can manually delete this overlapping triangle. Oops, let me just move one back further. Let me select this part again. Okay, I can mark overlapping triangle, which is somewhere here, and then delete mark. Okay, so there are 1 hole here, but no worries. Let's continue to use the algorithm. And then click until all the errors has been fixed perfectly like this. Okay. So there are no errors here anymore. All right, so now we can proceed to create the 3D texture on this part. Close this fix wizard window. So for example, if now I want to create a texture here, okay, in this area, there are several ways to separate out the surfaces. Now I will teach you 2 of the convenient way. All right, because if now, why we need to separate out the surfaces? If we didn't separate out the surfaces, we just select this surface, then the whole surfaces here will be applied, the texture will be applied on these surfaces, which is not correct. All right, there are already some surfaces has been separated like this, which is very good. Okay, so now I'm going to teach you how you can separate out these surfaces. So there are several ways. First of all, you can use the manual kind of separate surface way, which is by using the under the surface and then polyline. Okay, so this one you can manually draw the area that you want. Okay, I will just quickly draw. But you can draw slower to follow the shape clearly. Right. Now, after drawing a closed curve or loop, I will be able to select this surface instead of the entire surface here. So now the surface has been separated. Okay. Of course, there are another way. Okay, which is much more not convenient a bit, but it's much more accurate. I can go back. Okay, undo. There's another way called curve. Okay, so we can separate the surface by curve as well. For example, let's turn on the triangle edges. Okay, now I will draw the curve. Okay, based on this line. Okay, which is a little bit slower. Okay, because it will follow exactly the triangle edges. Okay, I'm not going to like draw the whole surface, but just to give you some idea on how I can do it. Like for example, I will just draw this area. Okay, so you can basically follow the curve and then draw out the whole surface, but I'm just giving you some example of how you can draw it. And if I now, okay, turn on the wireframe again, this surface has been separated out. All right, so this is another way, the more accurate way, but slower. And lastly, the fastest way would be, let me just undo. And now I switch back to the wireframe view, is by using the marking tool. Okay, so the marking tool is about marking the triangles. Okay, so for example, let's say I have some triangles here. If I use the mark triangle, I can mark the triangle one by one. Okay, or I can also use some other like wave, can draw some area and then mark the triangle, right? Rectangle to like draw a boundary and then mark the triangle. But this is still not the fastest way. The fastest way would be directly using the smooth region. Okay, so by using the smooth region, you need to set the angle of deviation. Like for example, if the angle is too big, like for example 10 degree, you click this surface, then anything fall within the angle deviation of 10 degree will be marked. Okay. So now I just want to mark this surface. I can use a smaller angle of deviation, let's say 3 degree, and I can accurately mark this surface out. After that, just right click, separate, move to surface, move to surface, create new. All right, now a beautiful surface with the good boundary condition has been separated out. All right, so this shows how important to mark the surfaces, to separate the surfaces, so that you will have the desired surfaces that you want to work with. Of course, if you can do it in your CAD software also. Some CAD software, like for example, in Rhino, for example, you can basically create the boundary condition and then save it as a 3D file where you import into Magics. This surface will be, the boundary can be retained. All right. So, but let's say if you don't have any like boundary, this is the way to separate out the boundary of the surfaces. So now I'm going to create texture on this surface. So the workflow of creating a 3D texture would be, first, you need to create a UV map. After creating the UV map, apply the bitmap or the image on this surface, make it a 2D texture. After creating the 2D texture, you can convert this 2D texture, become a 3D texture, STL kind of triangle. But converting the 2D to 3D texture is an optional step. If you have materialized Magic's build processor, then we can have the STL best texture where you don't need to convert to 3D texture in Trimatic. Right, first of all, I will need to create a UV map. Okay, so the UV map here, select this UV map. Okay, now I'm able to select this surface because I have separated it out. All right. So don't worry about this. Just set everything by default first. Apply. All right. So now there are two windows here. The first window is the 3D view, which I am working just now. And another window is called UV patch. So this UV patch is actually this like a surface in the UV map world. Okay, so the UV map world is not in XYZ, but it's in U, V, and W. Most probably you don't need a W because it's always 2D. You only look at the U and V. All right. So what are the importance of this? I would say like a square here, because your image will be populated in the square. For example, you have one image. Okay, it will be imported and populated in this square, and after that it will be repeating itself, populating all the surfaces. Okay, so the size of the square of the UV map, the orientation, the shape is very important. If not, if you didn't control the UV map nicely, your image will be distorted or your image will not be correctly populated on the texture itself. So we offer some tools for you to set the size. For example, now let's click this UV map. Okay, what does it mean by 10? Okay, 10 is a unit of 2 millimeter. So if you can measure, okay, so let me just measure. Okay, from here to here is actually 10 mm. Okay, and then from the other side, okay, but since this is a square, so it's also 3 mm. Sorry, it's also 10 mm. Okay. Oops, I accidentally closed my UV patch. Let me just open it back. Okay, because this is like a, if let's say you want to have a, like a, I would say not a square kind of a UV map, you can also turn off this key aspect ratio and become 5 and 10. For example, then it will not be a square image already or square UV map. Okay, but in this example, I will make everything to be square, easier for you to understand. Right, so you can control the size. Let's say if you want it to be smaller, okay? So this is one image, right? So if you want your image to be smaller, you can put 3 or even smaller, 2. All right, so it's quite flexible. Now I will maintain at 3 mm by 3 mm image. And also there are other, like for example, translate, rotate, scale. These are the functions that for you to have full control on your UV map. Okay, translate, like you can move it so that you can see that the UV map is moving as well. Okay, and you can also rotate it. Okay, become something like this. If you want to make it like straight like this. Okay, scale to make it bigger, smaller with certain factors, okay, that you can scale it. Okay, you can set the factor that you can scale it. Okay, the step size. And lastly, okay, optimize UV, I will skip at this moment because it's not useful in this case. Align UV, okay, align UV is like, for example, if you want your image to be really aligned, okay, to this, like if your image has certain direction, so you want to align your UV map so that this red color or the U or the V area is with this axis. You can select this UV map, and then this is an open surface. Entity would be from this line to this line, and I want it to I want to align the V, okay, the V axis, the green color, to be aligned with this direction. Add, apply. Okay, now you can see that all the green color axis is aligned to this line. Okay, so this is how you can use the align UV function. All right, so once you have your UV map ready, we can now go to apply the image or bitmap to this surface. After applying the image, you will appreciate the importance of this aligning or manipulating this UV map. Without further ado, I will go to texturing. So in the texturing function, this is where you can apply all the digital texture from 2D to 3D, or you can even do fading texture or ladder texture, which I will show in a while. Go to UV vest texture. And then UV map, I will select this UV map. Image, I can select any image that I have created. So inside Thematic, there are already some texture already created, after the installation. So you feel free to use it. If not, you can always create your own image. Okay, the image is in PNG, JPEG, or BMP file, can be accepted. But one thing to take note that the image that you created is good to have a repetitive image. For example, this honeycomb, the another image of this honeycomb will have a repetitive, can repeat itself, so that you will not have a clear seam on this map. Okay, let me show you an example. Now I will be selecting this zigzag. Okay, so you can see all the image are in black and white grayscale image. I'll select this zigzag, open, and then I will apply it on the surface. Now you see, so just now the map, right? Let me undo first. So you can see that now the UV map is like this, right? And just now after applying a zigzag, it will be populated in one of the UV map. I'll do it again, select this UV match, and then select this image. Apply. Is populated in this one UV map. So if you want it to be populated, okay, you can either select this function tile image at the start, or you can go back to the image here, use a tile image, then it will be populated like this. Okay, so this is how you apply a 2D. So if you look at the thickness, it does not have any thickness yet because it is still in the 2D, just like an image. And this is also explain why it is important to have a image that does not have a very clear seam, that the image is repeating itself. If not, if the image is not repetitive, then you can see a clear seam throughout this UV map. Okay, from here, it doesn't have any seam because the image that I created is perfect. So now, before applying the 3D texture, I think that, maybe this image is too small. I want to make it bigger. I can go back to my UV map function. This is 3 mm, right? Now I can change it to a bigger size, let's say 10 mm. Okay. So now this image is good enough to go. I would like to create this image to be assign a 3D information. Okay, so how can I assign a 3D information? I can select this image, and then there are white and black offset parameter here. White is nothing but this white color area. Black is this black. And let's say if there is like a gray area here, then it will be like if white is 0, black is 1, then gray is 0.5. Okay, so it depends on the color legend from white to black color. So now for this image, I want to set that my white color area is 0, which means it does not have any thickness from the surface. And the black color area, I would like to set it to be, for example, 0.3. Okay, so that it is 0.3 mm from the surface. If you don't have idea how does it look like, you can turn on this 3D view. Okay, so this is how it will look like after creating the 3D. So you can see that this area just now is like a gray area, right? So it will create something like the taper here. Okay. So now if I'm happy with this, let's say if you want to change further, like become 0.5, okay, then it will have more, this is 0.5. Okay, you want to change the white become inverted, white become 0.5, black become 0, can be done also. Okay, just change the value. Now I'll step it to 0.3 like this. Okay. So again, this is just a visualization. All right, so whether or not you need to convert it to the STL or 3D texture, then it depends whether you have the Magic software or not. If you do not have, then you will need to the Magic's build processor. If you do not have the build processor, then you need to use this 3D texture. Okay, and then selecting this image. After that, use existing value means the black and white offset that I set just now, and make it assign a detail size here. So what does it mean by the detail size? Because when we convert this 2D texture to 3D, all these images will be created, will turn to a 3D kind of a STL size, STL file or STL format. So all these are the triangles. So if your pixel is very small, let's say if I put it like, okay, if my pixel is 2 mm, for example, or sorry, not mm, it's 2 pixels, then the memory usage is 55 RAM for you to create the 3D texture. Let's say if I put that, if I put it become smaller, 0.5, then you need 937 MB of RAM. So which means the time take to create the 3D texture will be longer, and the triangle size will be more also. So now I will find the balance. Use 1 so that it does not take much time to create. And the memory usage is 234. Apply. Right, so now it has been created from 2D to 3D, like this. Okay, so this is the 3D texture already. And if you look at the triangle view, okay, this is how fine the triangle is. Okay, of course, this is with the pixel size of 1. Let's say if you put larger pixel size, the triangle size, the triangle number will be reduced, but at the same time, the surface resolution might not be that good. Okay, so you need to find the balance between these two. That's why just now in Manchun's presentation, he shared about like if you convert this texture to like triangles, then depending on the resolution, definitely the file size will increase. Okay, so let me just move back to this. All right, now you can see that, let's say if I don't want to have this kind of sharp edges at the edge, I want to have a smooth fading from the thickness here, slowly fading, become small to the edge. I can do that by selecting the fading feature here. Okay, with this, I will undo to go back to the 2D texture stage. Let's undo. Okay, now it's 2D texture. All right, and then I will make this image fading from black color to white color using this fading function. Okay, I'll select this texture or image. Fading guide, I can select this like a corner or the border. And here you can set the fading parameter. I will not go into detail. Basically, you can set what are the distance. Where does your fadings influence distance? From the edge, is it 1 mm or is it 2 mm to the middle of this border? And whether or not to be white color or black color. Now I'm using 2 mm with white color. Let's see the effect. Okay, so it becomes something like this. Okay, from this to become something like this. Okay, so this is very important because so that my texture will go from will gradually decrease the thickness. All right, now I'm going to do a 3D texture on this. Same thing, I will first go and put some number here for my white and black offset. Again, I put 0 and 0.3. Okay, 3D preview. Okay, you can already see from the preview, there is a decrease in the thickness on the depth. okay, at the corner area. Okay, so now I've set the value. Just go to the 3D texture. It's the same thing. Right, put 1 mm or 1 pixel. Apply. Okay, so you can see from here, there's like a smooth transition from 3 mm thickness back to 0.3 mm thickness to 0. Okay, so this is how useful this fading feature. All right, so we have successfully created a texture on one surface, but how about mask texturing? We are actually not into mask texturing yet. We managed to do digital texturing, but now I'm going to show you what you can do with mask texturing. Okay, so with mask texturing, let me just, for the time sake, I already spread out these surfaces. Okay, you can see that I can select those surfaces already because I already separated. So after separating it, let's say if this surface is with the same texture, I can directly create a mask texturing here. There is a filter of selection here because if you just select like this, it might be the surface is there, the texture is there, the connecting surface. So there are different kind of things for you to select, but I can just limit my selection to surface. Now, okay, now I can just select this surface, so use the control button to select all these surface. Okay, this is for the outsole of the shoes. Go to UV map, again, and okay, let's ignore the parameter here, and then just click apply. Right, now the UV map is like created across all the surfaces here. Of course, you can, again, for each one UV map, we can have different region, okay, all this region, but it belongs to one UV map. And you can directly change the size. This is 3 mm, then you can put 3 mm, for example, from 10 to 3 mm. Okay, and you can, if you want, you can select everything here and then rotate in one go. Okay, when you rotate in one go, then this will be rotated together. Same to translate, rotate, or scale. Yep. So now, just put 10 mm. Okay. And let's say if you want to do some alignment on certain surfaces, you can always use the align function again, and then just select this UV region. Select this UV region, align. Okay, and then let's say if I want this green color, the V, to be in this axis. Okay, just edit and then apply. So it can be done also. So now with all this image UV map, I can go to 3D texture, texturing again, select this UV map, and then select the image that I want. So this time maybe I use okay, the grip. Apply. So now it has been populated on the surface. And the next thing is, depending on you want to do the fading or not. If you don't want to do fading, just go to select 3D texture, select this UV map. Okay, and then choose offset like just now. Okay, maybe this line is 0 and 0.3, and the detail size I'll make it bigger a bit. Okay, apply. Okay, so it takes a little bit of time because as you can see that there are quite a number of triangle that is going to produce here. Okay, so it is done, and let's wait for a while. Yeah, so it'll be coming out like this, okay, on the surface itself. Okay, so this is how you can create a group, a digital UV map. And now, if let's move on to a more complex or outsole design. Okay, maybe something like this. Okay, so this is the end goal that you want to do. For example, if you have a very complicated outsole or midsole also. So in every area, the texture is different, and you can see the fading has been applied. Okay, but how are we going to apply this in the most efficient way? Let me just hide this first. And this is the original file, like this, after you have imported. Okay, first of all, in your software or 3D design software, if possible, you can group the surface with the same texture using the same color. Okay, you just group it in your CAD software. Then when you import into 3D, the color information can be retained like this. Okay, all this purple color means the same texture. Okay, this green, the same texture. When you import it into this 3D, these surfaces are not grouped together yet. However, these surfaces has been separated in different color. How can we group these surface together? We can use a function called under surface, group surfaces by color. Okay, so 3D will identify those with the same color code and then group them together. So group surfaces by color, and now this become a surface set, and this one become a surface set. So with the same color, it will be grouped together. With this, you can proceed to apply the 3D texture because now the surfaces have been grouped together. So for example, this one, I just select this surface group. You don't need to select one by one anymore because it's having group. Go to the texturing, UV texture, and select this UV map. Oops. First of all, before applying the texture, I need to create the UV map. All right. So UV map. All right. And then just click apply. Okay. So the UV map has been applied on this surface. Okay. I will not go into detail for the aligning. And the next thing is you can go to texturing, UV texture, select this UV map again, select the image that you want. In this case, maybe I will just put the honeycomb. Okay, apply. So it becomes something like this. Okay, I will show you another example. For example, now I will like to set this surface. So this surface is like something populated from the side and the middle also to the side. Okay, all these surfaces. UV map, create the UV map. Again, apply. So it will be take a little while because it's trying to detect all the surfaces here. Yep, sometimes it might happen that if there's some function running your computer, then the 3D might crash. Okay, let me just open out it again. And I show you the example again. Okay, open 3D and let me just import the file again to here. Yep, so this file is a little bit big, so it might take some time. Okay, so now I need to separate the surface again. Group the surface by UV, by color, and then select this group of surface again and create the UV map. Oh, this time is okay. Yep, so depending on the number of surfaces that you want to create the UV map, sometimes if your surfaces is like this, where you basically group most of the surface together already, and there are a lot of separated surface out like this, that it might take some time, okay, to create the UV map. But now you can see that the UV map has been created. Just go to the texture again. Every workflow is the same, okay, so you can repeat this workflow. And now I can choose another image, maybe this brown image. Yep, then it becomes something like this. Right? Cool. So repeat the workflow on other color, like this surface set has with other color. So that's about the mesh texturing using colors in 𝐜𝐴𝐴𝐷. And please allow me to show another workflow. It's about the midsole. Right? So I will just close this one first. And I will open another midsole. Okay, so something like this. Okay, a very simple midsole with don't have any design here. So our objective now is to apply some design on this midsole. Again, this midsole, because this surface is like a closed surface. Okay, open surface is something like this. Okay, this is an open surface. The surface is not connected to each other. But closed surface or mental surface is something like this. That the surface is like a cylinder where it's connected to each other. So before we can apply the 3D texture, one thing that we need to take note is we need to separate this surface, make it a line to separate the surface out first. Okay, so there are several ways to separate that. Okay, I will just use the simplest way. Okay, use the rectangle line. We'll just simply draw a line here. Okay, so now the surface has been separated into two, surface 1 and surface 2. And why I need to separate it? Because I need this seam. Okay, and then this is surface fin, and then I can make it a curve. Okay, don't worry about the workflow, but there's the tips at the back. So later on, if you have interest, I can teach you further on that. But now I will show you the workflow first. And then after that, I can just combine this surface back together. Okay, I will move one step back further first. Let's say if you didn't separate the surface, okay, like a full surface, without the seam here, if I go to UV map, the UV map created will be something like this, all distorted. Because 𝐜𝐴𝐴𝐷 cannot detect where is the line. So it will be something like this. When you apply your image, here will be very big and here will be very small, which is not good. Right? So that's why we need to separate out the surface. Right? So let me move back to here and then use the rectangle. This. Create a new curve. Now I will merge the two surfaces together. Right now I have a full surface like this, but I have a seam. I have a line here. I can go to UV map. Okay, so for the mental surface or the closed surface, you need to define this seam, which I already defined, and then click on apply. So here, it is much more better than just now. Okay, the shape here is become normal also, but there are also some misalignment here. Okay, which your image will be discontinued. So you can use this align UV again. So this UV map, and this time I will use automatic. Automatic means it will based on the surface area and curvature align the UV. And now it looks much more better. All right, so you can do it automatically or manual way also. With this, let me just apply a UV map. Select this one, not UV map, a texture. It's the same thing. And this time I will use, let me see, maybe let me just use a line. This is more suitable. Okay, this one. Apply, then it becomes something like this. So from here, 3D texture, you can set the white and black offset again. Okay, the size I will put smaller size, yeah, 10 mm, 10 pixel maybe. Apply. Okay, so this kind of a texture can be created on the midsole. Sorry, so it depends on your accuracy. If you want to have more accurate shape, then please use a finer detail pixels. Although the time taken to generate this pixel will be more, but it definitely give you a more accurate surface. Okay, so this about like something that you can do with the midsole. But let's say if you think that, oh, you said, you see this is the like a actually distorted, you know, the line, you don't want to have a line like this. You don't want to have a line from like a curved line, you want to have a straight line. Okay, then you need to realign your UV map. So to realign your UV map, okay, from this kind of a shape, you can just hide this image first. Okay, because the image will follow the shape. The image will follow the UV map pattern. Okay, so I can do further alignment, like for example, UV map, align, select this texture. This time I use manual. Okay, choose this sim. Entity, the V will be follow the line from here to here. It's like a straight line. And also here to here. Okay, the V is a green color. Okay, and the U, okay, the red color, I want it to be as straight as this line. Okay. After this, just click apply. Yep, so now it becomes a straight line. And if the U becomes a straight line, and then the V, the green color, becomes a straight line also. So now if we unhide the image again, yep, so the image will always follow the UV map. It becomes straight again, the image. Okay, so this is how important the UV map and also how you can align it to fit your requirement. All right, so that's about something that I will need to show. I might be running out of time, but later on, if I have more time, I might show you another workflow on the lattices. Okay, but before showing the lattices, I wish to move to Magics first. Okay, so for example, if I already have this file, okay, that have the UV map show only. Okay, that already have the UV map image. It depends whether I want to convert it or not. If let's say I have Magic's build processor, I don't need to convert to 3D. But so I will show you if you have the Magic. So now I don't need to convert. I can directly save this file, and then I will open Magic's. Okay. Okay, so it's here, and I can select. So Magic is a universal software that is not like tied to any machines. As if you have any like maybe Formlabs machine, SLI machines, or other Union Tech or any other machines that you have, you can connect with. You can use Magic as well. Now I just use a generic machine A, for example. Okay, and I will import this shoe that I have created just now. Okay, something like this. Okay, this is a shoe with the 2D texture. It's not 3D yet. Imported. Okay, so the benefit of using this slice-based technology is that I don't need to convert into the 3D texture, and you see it's very fast, and the triangle size is very small. All right, so it will give you more save your time in support generation, orientation, or even sending the file to your colleagues, things like that. Okay, there are a lot of benefit. So let me just put in the platform center. And now I want to print it out. So first of all, this is not a good print orientation. I want to face the texture on outwards. So I will just rotate it by 180 degree, something like this. Okay. So now it depending on whether you want to print it out like this, okay, a horizontal kind of orientation, or you can also orientate it based on certain degree. Like maybe in this case, I just simply rotate by 25 degree so that it can give a angle like this. Right. So the next thing is I just need to generate the support. Okay, so the support generation, there are different kind of support that you can generate, but I will show you a simple and quick one, which is using 𝐬𝐧𝐧 support. Okay, so to generate support, all right, here is the 𝐬𝐧𝐧 support parameter that I already set. So let's say if you are not happy with the support parameter, you can always change different kind of support parameter that you want here. Okay, now I will not do anything. Just generate the support. Yep, so at this point of time, Magic is trying to find those critical areas that need to generate support, and placing the support on it become like this. Okay, so this is what we call the 𝐬𝐧𝐧 support algorithm, where the support is very light and at the same time strong enough to cover the critical area. Okay, so with this, you can use our build processor to build. Okay, and then just select build, submit. I will not submit now, just submit the job. And this kind of file will be sliced, and also the information, the 3D information here, okay, 0 mm and 0.3 mm kind of thickness will be directly sliced. So you don't need to directly convert to 3D texture. This is how we call the slice-based technology. All right, so that's an overview of the fixing and also 2D creating UV map, separating the surface, aligning the UV map, 2D and 3D texture. And after that, come to these magics for build preparation and support generation. I actually have more things to show if I still have time, but I'm supposed to be stopped at 3:30 Vietnam time. So yeah, maybe Ivy, shall I continue or shall I look at the questions and answer some of the questions if there's any?
Oh, actually, we do have some question here. Maybe we can answer it first before we, if we have time, we can go on with the demonstration.
Okay, sure.
So for the first question, our audience asked, is it possible if I group the surfaces in Rhino by color or layer before imported into materialized 3D for creating texture?
Yes, this is a good question. Thank you for it, because yeah, this is one of the questions that a lot of customers ask also, because Rhino can actually group the surfaces with color first before you export it to 3D. Of course, you can do it in 3D. Let's say if your surface doesn't have any color, you can put the color here. But the best way would be first created in your assign the color in Rhino before exporting to 3D. So this is the file. The example that I showed you just now. Oh, I already closed. The examples that I showed you just now with a lot of colors, right? It's actually from Rhino. Yep. So the answer is yes. Please do it in Rhino first.
Okay, great. And there is another question. They're asking about the document for learning thematic.
Yep. So the document learning thematic, first of all, let's say if you are interested with thematic, so depending on the business cases, we can offer you a trial license. Okay, but this is subject to discussion. When you have the trial license, we have a tutorial here. Okay, and it is directly oh, sorry, this is for yeah. So let's say in the thematic, there is a tutorial here, and from here there are a lot of example, including 3D texture. Okay, like lattices, texturing, a lot of example with the function explained in thematic. So you can use this document, and inside our website here, okay, beside Magics, we also have thematic tutorial in our website, which maybe later on I can share in the chat box also.
So can I ask about like how long will the trial last?
It also depends, okay, because yeah, it also depends, but usually we'll start from 1 to 2 weeks. Yep. Let's say if you need further like examination or evaluation, only then we can consider to extend it. Yep. But we always start with a purpose. Like for example, you want to really focus on this application, then we will define a goal. Then we together help you to achieve the goal in 1 or 2 weeks time, so that we don't waste the time when you are having the trial license also. Yep.
Yep, sure. Okay, so there is another question, like can we do lightweighting for the sole with this software?
You mean wet the
lightweighting?
Oh, lightweighting.
Yep.
Okay. Yep, lightweighting is something that I actually wish to show later about the lattice generation. Yep. Maybe if later I have time, I can definitely show to you, but the answer is yes.
Oh, cool, it's cool. And also the other question, I think is probably for Moonjun. Maybe do you think that we should move into the Q&A section right away?
Ivy, I think you missed out a question. So there's a question that asking about can the result be used on conventional manufacturing methods such as CNC or laser engraving?
Oh, sorry for that.
First of all, if you want to use it in the traditional CNC, you have to convert. Most probably, you have to convert this file to not the STL file format already, but to stat format. Okay. Yes, thematic can help you to correct in the stat format, but the thing is, it might be difficult. It depends on the complexity, because let's say if the texture creator is very small like this, then maybe the conventional kind of manufacturing cannot be used. But let's say for something like this, okay, that is very simple, just a sum line. Then depending on what kind of file format that your CAM software can accept, most probably it's a stat file format. Then inside thematic, we are able to convert this part to stat file again. Yep. I hope I have answered your question correctly. Let me know if you still have more questions on this.
So we have another question from the live stream. Does the software support product rendering, or can it send a model to popular software for product rendering like Keyshot or V-Ray?
You mean like something like rendering the image, is it?
Yep.
Yep. So for images rendering, thematic is not a software for you to do picture creation, rendering, or Photoshop. Not. So you still need the proper software to create something like this. Okay, like an image. Okay, just one example, like something like this. Okay, so that you can after that export it from your Photoshop or any design software to PNG, JPEG or BMAT file, and it can be read by 𝐜𝐴TIC after that.
Okay. All right. I think that we shall have like about 5 minutes to do like the waiting in the materialized schematic. Is that okay for you?
Yep, good enough. 5 minutes.
Oh, I'm sorry, but there is one more question.
Yep.
Is 𝐜𝐴TIC already support Windows 11? And can we do an alpha map in Photoshop and import it into 𝐜𝐴TIC?
So sorry, the first question is 𝐜𝐴TIC can be supported in
Like,
Windows 11. Yes, it can be supported in Windows 11. And the second question, can you repeat again?
Can we do alpha map in a Photoshop and import to 𝐜𝐴TIC?
Yes, definitely. So basically, like what I mentioned just now, you still need a Photoshop or a design software to create the image. Then you can export it in the PNG or JPEG file. Then after import to 𝐜𝐴TIC. Yep.
All right, thank you for your answer.
All right, so if no further question, light wetting is a very interesting topic which I wish to show it to you now, right? So let me just open up this one. All right, so if you look at this shoe, this at the back, at the bottom, the outsole is by the texture with some fading. But if you rotate it, okay, it is like a lattice structures. Okay, we call it the light wetting also. So for these lattice structures, okay, how we can I'm going to show you how you can create it, but basically you can combine different lattice structure in different area of the shoes. Even the thickness you can vary also. Okay, so the good thing about 𝐜𝐴TIC, first, the texturing function is very powerful, and second is a light wetting lattice function. I will quickly show you how we can do it. Okay, let me just hide this. Okay, now I have 3 parts here in different color. So the outer sole will be something like shawny. Okay, will be something like just like this. Okay, so I'm going to fill everything inside with lattice, but not the same lattice. I have midsole. Okay, which is the outer layer and the insole. All right. So the midsole and insole, I will use a different lattices to show how it can be done. So we start with a simple one first, with the midsole. I will click show only. Okay. So this one, first of all, before creating the lattices, we need to import the lattice. Okay. So the lattice is about the unit cell. Whether I have any slides here too. Okay, it's okay. So the lattices, I will show you what does it mean by unique cell. Let's say now in the library, I have different unique cell. I will just need to import one, the diamond crystal. Okay, so it is something like this. Okay, this one you can create your own, or you can use the one in the library. Okay, so the workflow is I'm going to populate this unique cell to whole part of this thing. All right, so how can I do it? First of all, we don't need the UV mat anymore. Okay, we need lattice. Okay, inside lattice, there are a bunch of functions here where you can do a lot of customization. Okay, I will show not all, but some of the important functions here. So unit best, okay, we'll select the mix cell. And okay, I want to change this, so I'll select this. So the unique cell, I will select this one that I just created. Okay, so now it's like a transform or become like something translate, become like this. And you can select the size that you want. Like for example, this is 10 mm. It can become smaller, 5 mm. Okay, or even smaller, 2 mm. Okay, so I will not go to too small. I will just use 5 mm. Apply. Okay, so this is something like a conformal lattice as well because it's follow the shape of this part. And then there are some lattices that is not connected like this. Okay, it might give you errors if you do it in 3D printing. So what we can do is we use the filter beam function to filter all those loose beam. Okay, and select this lattice and then delete. Okay, delete all this loose one. Apply. So all these loose beam will be deleted. Okay, so this gives you a better lattice structures. And secondly, this lattice structure, you can create, okay, this thickness is the default thickness, which is by default is 0. If you want to have maybe 0.5, okay. Oops. Is it changing? Yep. For example, if I put 1, you can see that the thickness of the lattice is changing based on the size that you put. Again, this is another slice-based technology that Materialize can offer because we don't need to convert this lattice to STL format. Okay, we can directly remain this lattice as this kind of visualization stats. And after that, put to Magics and use the slice-based technology build processor to slice it. Okay, it will definitely save a lot of file size. And now I'll go to install. Okay, install, I need another kind of lattice structures. So again, I need to import the lattice. This time I will use maybe this one. I believe it's more suitable. Okay, so these lattices you can always create your own, and it looks something like this time. Okay, so it's a bit different already. And with the same format, unit cell base and unit cell, I will choose this one, and the size I will give it let me check the size. It's like this, maybe it can become bigger a bit. 5, okay. 5 should be okay, right? Apply. Yep. So another like lattice has been generated, but this time I can do further modification because first of all, I can assign a thickness that I want. By default is 0. Now if I put maybe this one, so this one, I can put 1. Yep, then generally it will become bigger. Not only that, I can also use some more advanced function, like for example, because the shoe lattice might have different density in different area of your, our foot, right? So we can use the linear gradient, okay, and top, yep. So this linear gradient, I can put some graph, like from how much to how much, from minimum thickness 0.2, maximum thickness is 1.5. Okay, so now the thickness is slowly increasing across this axis from 0.2 up to 1.5. And if I'm not happy with this, I can always move it down to become lower thickness, move it up to become higher thickness. And I can also add more interval, like I can add 1 more interval here, then increase it, kind of something like this. Okay, this I move it down further. Apply. Then you can see that the lattices basically will have different thickness across the density. Okay. Another useful function is, let me just set back to 1 mm uniform thickness. Another useful function is by using the image base. Okay. So for example, now I just imported a foot image. Okay, just like your foot pressure. Okay, so the foot pressure can be something like, you know, some of the medical people with not correct kind of position foot, there might be higher area, higher pressure on certain area. So you can create these kind of images where maybe here have darker image, here have lower have a gray image or there have a whiter image, so that it can match out the pressure. So this pressure, when you put it inside Trimmatic, okay, if you give you a different thickness, okay. So now I will go to the bottom view, and let me try to fit this small fit to my yep, maybe something like this. Okay, so now I can set white color. It's the same thing. White color, what is the thickness? Maybe in this case, I put 0.2 to 1.5. Okay, so it depends on the image color. Apply. Cancel. Right, so you can see that the area with the high pressure or the map, the black color will have a high thickness, and the area with the white color will have a low thickness, which is 0.2. Okay, it'll be something like this. And if we just unhide everything, show, and also show again. So this is our shoes, an example of our shoes with lightweight structures. All right, so sorry, I take more than 5 minutes. So basically, this is how lightweighting can do in Trimmatics.
Okay, thank you for your sharing, Casey.
Yep. No worries. Any more questions?
Let's see. Right. So I think that we shall move into the Q&A section right away, right? Okay, so let's welcome Moonjun and Casey back. All right. So I have several questions that I gathered from the register form. So the first question is that how much cost saving per year can a shoemaker get after using materialized software in their production process?
Maybe I'll take that questions. So the cost saving will be very depending for each companies itself, because it involves on various different factors. But of course, like for example, if you have actually adopted Trimmatic in your workflow, and then this will also save your time in terms of like without the needs of outsourcing it to the third party, and then you will also save times on other different aspects as well. So I'll say cost wise it's various, but definitely in terms of like the total cost of ownership sort of it when you adopt 3D printing in-house, that will greatly save not only on your time but also on your cost itself. Yeah.
All right, thank you. So another question is that can a 3D printed shoe be practically and widely applied?
Sorry, come again, the questions?
Oh, sorry. Okay. So another question is that can 3D printed shoes also like the shoes that are designed by Trimmatic can be practically and widely applied?
Yep, I believe you can tell like from the example and also the demonstration that I showed to you just now. Within a few minutes, or you can already see much of the texture can be directly populated. And so practically, yes, the answer is yes, because we have a lot of customers already using it for their digital texturing, and also 3D printed out the shoe sole, and after that made the shoe ball. Yeah, so practically, yeah, it can be used, and yeah, it can be also widely applied in the sense that, not only the plastic or resin printing, but it's like what Moonjun showed, we are now also moving to metal printing as well. So with the metal printing of the shoe mold, it definitely will speed up the production process of the shoe mold. Maybe Manchung, if you want to add anything, you can add on. Yeah.
Yeah, like what I mentioned in the sharing just now, there's already some companies are actually already doing that, you know, they can actually directly print out from the printers itself, of course, using various different software. That is already you know, one proven application that is already, you are ready to see in the market already. There are some 3D printed shoes that you can actually find in the market itself.
Okay. So there is one more question related to the software. If possible, lock the texture when 3D model grading. Is that possible?
May I know what is 3D model grading?
Yep.
I maybe you can explain through Lee. Maybe you can explain further what is what do you mean by 3D model grading?
Okay. So let's leave that question beside, and now let's have like another question. Is that what are the advantages of 3D printed shoe soles compared to the traditional ones?
The advantages of 3D printed sole compared to the traditional one, is it?
Yep.
Okay. So also mentioned in the sharing itself is that the 3D printed shoe sole itself, it will be much more faster. You can actually control that, doing that in-house if you have a printers. And then it's a direct digital manufacturing methods. So you just need to have a CAD, and then with the 3D textures populated in the shoe sole out of it, and then you can just fabricate it out. So for traditional manufacturing, then you will need to go through various different processes, like going through the CNC method, and then you need to create you know, the pasta mold, and then eventually after that using that to create the metal mold itself. So with 3D printed way, then you can actually save those kind of processes, and also you know, promoting more sustainability and also protect our environment through the process itself.
Yeah, sure. Okay, thank you for your answer. So maybe there's one more question. Is there any user support or resources available from the software provider, such as the training programs, technical assistant, or online communities?
I think these questions, yeah, it's quite similar to the one of the questions that's being asked. Like, is there any documents to learn about Trimatic? So, like what Casey has shared just now is that there's a PDF tutorial that you can actually refer to, and then there's some links over in the online tutorial video that you can actually refer to as well. Yeah, maybe Casey, if you want to add on something on this one, if I miss out any.
Yep, sure. So usually during the trial process, depending on your application that you want to try, we will make sure that let's say it's relevant to Trimatic, we'll make sure that you will be able to really fully utilize Trimatic for your application during the trial. And if you're happy with this software, and after purchasing this software, our team, application team, will give you an onboarding training using Trimatic. So to make sure that you will be able to really use it for design and production after that. And after the onboarding training, let's say if you have any questions, we have like a hot ticket email system. That inside this hot ticket email system, there are 5 to 6 engineers that is standby readily for your questions. I hope this give you an overview of our support system.
Yep, thank you for your answer. So as for the question about 3D model grading, she means that can we lock up the texture when grading the 3D model into another size? I guess like when can we lock it?
So
like, make
the
it
question
bigger?
is that if let's say we work with different shoe sizes, can they actually lock up the texture sizes or scale it up into proportionally when it works with different shoe sizes? If you understand it correctly, yep.
Yeah, this is a very relevant question. The answer is yes. Basically, if you remember what I showed just now on the scaling of the, there's one scaling function in the UV map. So it will not be automatic. Before convert it to 3D texture means if it is remaining in the 2D texture, when you scale or rescale your model, the image will not directly scale also. But you need to do one more step. It's like you go to the UV map and then scale again the image based on the total scaling on your 3D model. Yep.
Yep. So there will be a function to do so.
Yes.
So another question about the software, like, do you have any option to sell only the software?
If I understand the question correctly, is that you are asking if there is any other options rather than to buy the software. If I'm wrong, just feel free to type in the chat. But yes, if you are working with some, let's say, projects that you wanted to engage with us, we do provide some services as well based on project basis. But for that, we will need to further discuss and to evaluate on the projects and see, and then we will actually, if let's say if it is falls within our scope, then yes, we can move on and to provide services out of it.
Okay.
I think the question is, do you have any option to sell only the software? So that means maybe thinking, and the audience is thinking that we are selling something more than the software.
Oh, is it maybe possible like software with printer?
Yeah, probably
maybe,
that.
Yeah. Okay.
The audience is thinking. Yeah. We actually Materialize is only selling the software. Right?
Yep. So if that's the questions, yes. Yep.
Yep. So
Sorry,
yeah. In addition, like just now when if you can look at Magics and 𝐸matic, we don't like connect or just fit for certain technology or printers. Yeah. So let's say if you already have the printers and you have like different kind of printers, you can always use Magics and 𝐸matic also. It will be fit to your design and also preparation process as well.
Thank you for your answer. So for the audience, if you have any further question, please feel free to send the question into the Zello group. So I can ask the representatives of Materialize to answer it, and we will gather on the question as well as the answer to post on the social medias of 𝐕𝐢𝐧𝐃, including like Facebook and LinkedIn. So don't worry if you don't worry that you won't miss any question. Okay, so that's the last questions of the Q&A, and it's also the end of the webinar. Once again, on behalf of 𝐕𝐢𝐧𝐃, I would like to send a sincere thanks to Mr. Moon Chun Lim and Mr. Casey Law from Materialize, as well as the presence of all the audience today. And 𝐕𝐢𝐧𝐃 is currently the official distributor of Materialize in Vietnam. If you would like further consultation or assistance regarding the Materialize 𝐕𝐢𝐳𝐃, please feel free to contact us using the information displayed on the screen. And 𝐕𝐢𝐧𝐃 hopes to hold more and more conferences as well as the webinars in order to bring the latest knowledge in different fields to everyone. So until next time, stay inspired and continue to innovate. Goodbye and see you.
Thank you, Martin and Casey, for your presentation. Very insightful. We got a lot of questions from the audience. Thank you, everyone.
Okay, thank you. Moon and Casey, maybe you can now leave the meeting right away.
Okay, thank you everyone. Bye bye.
Thank you.
everyone.
Goodbye.
Bye bye.
See you.
Bye.
Thank you.